So hopefully you were able to do the 6-1 lesson, which was on polygons in general. So on that one, we talked about how to name them, triangle, quadrilateral, pentagon, hexagon, and so forth. We also talked about how to find the sum of the interior angles, so that was n minus 2 times 180, and how to find the sum of the exterior angles, which is 360, and it's always 360 if it's the exterior angles. So today we're going to narrow this down, and we're going to talk about a very special quadrilateral called the parallelogram. So a parallelogram is a quadrilateral that has 5 unique properties, and we're going to go through those now. So the first property says that a parallelogram is a quadrilateral with both sets of opposite sides parallel. So the top and bottom are going to be parallel, and then the left and the right will be parallel. All right, so again, the first property, a quadrilateral with both pairs of opposite sides parallel. The next property says if a quadrilateral is a parallelogram, then both sets of opposite sides are congruent. So the top and bottom are going to match, and the left and the right are going to match. So both sets of opposite sides are congruent. The third property says if a quadrilateral is a parallelogram, then both sets of opposite angles are congruent. So these two angles are going to match, and then the other two angles will match. So again, both sets of opposite angles are congruent. The fourth property says that if a quadrilateral is a parallelogram, then consecutive angles are supplementary. So what do we mean by consecutive angles are supplementary? What we're saying is consecutive means right next to, and supplementary we know means adds to 180. So we're talking about these two angles would add to 180, and these two angles would add to 180. And then these two angles would add to 180, and then across the bottom would add up to 180. So every angle next to each other adds up to 180. And then the last property says if a quadrilateral is a parallelogram, then diagonals bisect each other. So diagonals bisect each other. That means the diagonals cut each other in half. So if I look at this first diagonal, those two pieces would be the same number. And then the other diagonal, those two pieces would be the same number. So we're going to use these 5 properties to solve some problems. So when I look at these, I want you to think about what property are we using. So if I look at number 1, this one is angles next to each other, just like example number 4. So this is like rule number 4. And it says that these have to add up to 180. So x plus 130 equals 180. Subtract 130 from both sides, and we get x is 50. Okay, the next one's dealing with sides, and it's dealing with sides across from each other, so opposite sides. So that's going to be like property number 2. So I just set it up, 5x plus 2 equals 6x. Subtract 5x from both sides, and we basically get x is 2. Okay, looking at number 3. Now this one's dealing with angles, and instead of being next to each other, these angles are across, like opposite each other. So if I look at those properties and I'm looking for opposite angles, that's going to be property number 3. And it says that opposite angles are congruent. So that means they're the same. So x has to be 35. Number 4 again is dealing with sides, opposite sides. So that's going to be example number 2 or rule number 2. So that means they have to be congruent or equal to each other. So we're going to add 2 to both sides, 3x equals 21, and divide by 3, we get x equals 7. All right, so continuing on, number 5, that one looks like property number 5. So this one is the diagonals bisect each other. So that means this piece and this piece have to be congruent. They have to be equal. So 4x minus 1 equals 3x plus 4. Subtract 3x from both sides, and then add your 1, you get x equals 5. All right, now number 6 is the same property, right? It's dealing with diagonals again, but this one's going to be a little challenging. So if I look at this one and I look at this diagonal, it's telling us that 3x minus 1 has to equal y plus 2. And then I look at the other diagonal, so this piece has to be equal to this piece. So if I write that out, I would get y equals x plus 3. So this one is a system of equations, and I know it's been a little while since you've seen it, but basically we're going to substitute x plus 3 in for this y. So my new equation is going to be 3x minus 1 equals, and instead of y, I'm going to put x plus 3. And then I have to finish my equation plus 2. So now I can add all this stuff together. So I'm going to simplify it. So we get x plus 5. Subtract an x from both sides. I get 2x minus 1 equals 5. Add 1. 2x equals 6, and divide by 2, we get x equals 3. So there's my first answer. Now I'm going to plug that x into that other equation. So y equals x plus 3, so we know x is 3. So y has to equal 6. So that is the hardest type of problem that you're really going to see today. Now 7 looks like it would be hard, but this one's dealing with sides, and if I look at the opposite sides, they both use an x. So I know opposite sides are going to be congruent. So this is property number 2. I guess I didn't tell you that this one was property number 5. Okay, so 2x minus 4 equals x plus 4. Subtract an x from both sides. Add your 4, you get x is 8. So you would have gotten the same answer if you would have set up the top and bottom equal to each other, but I only had to choose one set. Okay, now number 8, again, looks like it's going to be complicated, but if I look at opposite angles, for instance, those are both x's, and I know from property number 3 that opposite angles have to be congruent. So 3x minus 15 has to equal 2x plus 25. Subtract 2x from both sides, and then add 15. So we're going to get x equals 40. I could have set the other two angles equal, or I could have used consecutive angles or supplementary, and I could have added this angle and set it equal to 180, and I still could have gotten the same answer. So just because I'm showing you one way doesn't mean it's the only way to solve a problem. Okay, looking at number 9, now this one looks like property number 4 again. These angles are right next to each other, so that means they have to add up to 180. So 3x plus 7 plus 110 equals 180. 3x plus 7, oops, let's try that again. So 3x plus 117 equals 180. That looks better. Subtract 117 from both sides, and you're going to get 3x equals 63. And then we divide by 3, we get x equals 21. Number 10, these are angles again. These angles are opposite each other, so that is going to be property number 3 again. So we're going to have 3x equals x plus 60. Subtract an x from both sides, and then divide by 2, we get x equals 30. Okay, number 11 looks very similar to number 6 up there. So this is using property number 5, your diagonals. So we know that these two pieces have to be equal. So y plus 4 equals 3x. And then we know that these two pieces are going to be equal. So y equals 2x. And I'm going to plug this 2x in for this y. So I'm going to have 2x plus 4 equals 3x. Subtract 2x from both sides, and we get x is 4. I always like to write it the correct way. And then I'm going to plug that in here. So y equals 2 times x, and we know x is 4. So y equals 2 times 4, which is 8. All right, last type of problem. Now this one you're going to have to use a couple tools. So we're looking for 3 angles here. We got to find angle 1, angle 2, and angle 3. Okay, so I know that these two angles are a linear pair. They make a straight line. So 180 minus 82 gives me 98. So that means angle 2 has to be 98. Okay, now I remember from last try, we could look for z angles. So z angles are your alternate interior angles. So in this case, angle 3 and angle 50 have to be the same number. They have to be congruent. All right, so I know angle 2 is 98, and I know angle 3 is 50, and we know the 3 angles inside a triangle add up to 180. So we're going to have 180 minus angle 2, which is 98, minus angle 3, which is 50. And when I subtract those, we're going to get the angle 1 is 32. So on the homework, basically you're going to figure out which property am I going to use. This one used like chapter, I think that was 3 and 4. So this one was using like extra properties. But everything else used one of the 5 properties on the notes today. And then this guy, I wanted to show you one of these because you do have 2 of those on your homework too. But if you use which property are you trying to use, so think about what property am I trying to use, and does that make them congruent or supplementary? So that's basically all you're trying to do. If you have any questions, let me know.